Alright, this is exam review number 2, and I'm going to continue working the exam review problems so that you can work them at your own pace. I'm going to set the clock here so I don't go over time. Alright, let's start. The second problem deals with continuity, and just to remind you, continuity has to do with whether or not a function has no breaks, no gaps, no holes. No breaks. In other words, that would be more like a vertical asymptote. No gaps. That would be what we would call a jump discontinuity, and no holes. Another way to talk about continuity is if you can draw the graph without lifting your pencil. One of the things that we're very concerned about, particularly when you see the first problem in number 2, is that we have a variable in the denominator. Anytime we have a variable in the denominator, there is the possibility of a discontinuity. You can see from the factor in the denominator, if we set x minus 1 equal to 0, we get x equal to 1. So there would definitely be a discontinuity at x equal to 1. So f of x is not continuous. So we're going to get rid of that one. The second one is the graph of ln of x squared minus 1, and we're worried about continuity at x equal to 1. Now, it doesn't say is the function discontinuous anywhere, but it says particularly at x equal to 1. So it makes sense to substitute 1, and when we substitute 1, we get ln of 1 squared, which is 1. And then we have ln of 1 minus 1, which is 0, and we have the ln of 0. Now, we're trying to determine if we can evaluate the ln of 0. Remember, the base of the ln is e, and e to the first, e to no power is equal to 0. We can't take the ln of 0, and if you think about the graph of the ln function, or the basic ln, well, this is x squared minus 1, so I'm not even going to mess with the graph. Can't take the ln of 0, so the function is not continuous at x equal to 1 because there's no y value. Now, in this problem, our first reaction might be to think, okay, there's a discontinuity here because x cannot be equal to 0. Well, that is a true statement. There is a discontinuity at x equal to 0, but that's not what they asked us. The question is the function continuous at x equal to 1? Well, if we substitute 1, and I don't know what the sign of 1 is. That would be a calculator issue, 1 radian. But there is a sign of 1. And if we divide it by 1, we'll get a value. So in other words, we are outputting a y value. And since we are outputting a y value, h of x is continuous at x equal to 1. And that was the question. Problem number 3, we're doing a series of derivatives, and you need to go back and just make sure that you have reviewed all your derivative rules. In the first problem, letter A, we have ln, and the derivative of ln is u prime over u. So when we find the derivative, and in this case, 5x is u, so the derivative y prime would be u prime 5 over u, which is 5x. Now, of course, that can be simplified, and the 5's will divide out. Now, be careful with 9 over x. Your first reaction might be to write it as 9x to the negative 1, but if you try to find the derivative, oh yeah, we are finding derivatives, not antiderivatives. Alright, so when we rewrite this as 9x to the negative 1, by the power rule, we'll get plus 9x, decrease the power to the negative 2, and we can rewrite our answer to be 1 over x plus 9 over x squared. Now, if this were a multiple choice item on your exam, then they might have the answer written with a common denominator, and you would have to find that common denominator. But notice in that second term, be careful, because we have been taking antiderivatives. When I looked at the 9 over x, I was thinking antiderivative versus finding the derivative, so be careful. Letter B, we have a quotient, and there's really not a whole lot we can do to change that, so we're going to have to use the quotient rule. Remember, the quotient rule is down, so that's the bottom function, d up, and so the derivative in the numerator is 3, minus up, that would be the factor in the numerator, d down, the derivative of the denominator is 1, over down, down. And so in the numerator, and in the interest of space, I'm doing this, so I get 3x plus 6 minus 3x. Make sure you distribute the negative to the negative 4 plus 4. So my final answer would be 3x minus 3x is going to subtract out. 6 plus 4 is 10, so I get 10 over x plus 2 quantity squared. Now, if you see any errors or notice any errors in any of my work, please feel free to come and let me know and challenge me. I am doing these kind of fast, so there's possibility of a careless mistake. Letter C. In letter C, we have the product rule. We have a binomial multiplied by the cosine. So I'm going to do the work down here. When I use the product rule, I have the first function times the derivative of the second. The derivative of cosine is negative sine, plus the second function, cosine, times the derivative of the first function, which is 6x. There's not a whole you could take the negative sine x and stick it in front of 3x squared plus 5. I don't think distributing makes it any better. You could put the 6x in front of the cosine x, but there's not a whole lot more you can do with that. Letter D. Obviously, we want to sprinkle some algebra, and we'll have y equal to x cubed plus 7 to the 1/2 power. That is a chain rule problem because there's an inside and an outside function. So y prime would be 1/2 of the quantity x cubed plus 7 to the negative 1/2 multiplied by the derivative of the inside, which is just 3x squared. In writing my final answer, which again I'm going to bring down here, I would have 3x squared in the numerator. The 2 from the 1/2 is already in the denominator, and because I have a negative power, I'm going to bring that to the denominator and get x cubed plus 7 as my final answer for letter D. I'm going to clear this, and I'm going to make room for the next few problems. In letter E, we are applying the chain rule again, at least to the first term. Remember, this is the same thing as sine of 6x quantity squared. So this is a chain of 3 terms, so be careful with that. This would be the square would be the outermost, sine would be next, and 6x would be last. So when I find the derivative of that, I will have 2 of the quantity sine 6x technically to the first power. Then I'm going to take the derivative of sine, which is cosine of the angle 6x. So notice I didn't do anything with the angle there. Multiplied by the derivative of the angle, which is just 6. That's the derivative of the first term. Second term, we're going to do simple power rule, so I'll bring down the power and multiply by the coefficient, 4/3 x. Decrease the power by 1. 4/3 take away 3/3 is 1/3. Pretty much the only cleaning that I could do here would make this be 2 sine 6x cosine 6x. Oops, I forgot the 6 in the back. Let's make that a 12 plus 4/3 x to the 1/3. Letter F, that is a symbolic derivative. There is clearly an inside and an outside, so the derivative of the outside would be f prime. Leave the inside alone. Then multiply by the derivative of the inside, and that's your classic chain rule. Letter G, I have product rule. So be careful in letter G. This is one that students often overlook, the product rule, because it looks like one term, and it is one term, but it is a product, and oftentimes students don't see it because there are no grouping symbols or anything. So it is the first function t squared times the derivative of the second. The derivative of sine is cosine, plus the second function, sine t, times the derivative of the first, which is 2t, and that's a pretty simple problem. Letter H, we have, now the negative 1 does not mean to move that to the denominator. That is the same thing as arc sine. So you need to go back and review your derivatives for arc sine and arc tangent. The derivative here would be So we get u prime, which is 3, over the square root of 1 minus u squared, which is 9x squared. Then we have the derivative of tangent, which is secant squared x. Now, the term that we have, the last term is the same thing as x to the negative third. So when we apply the power rule, we'll get plus 3x to the negative 4. And pretty much the only thing you could do to clean that up would be take the x to the negative 4 to the denominator. Alright, I'm going to get rid of that, and I'm going to do the last problem, or the last derivative problem that we have here. First term, this 5 is just a coefficient, so don't let that throw you off. In fact, I would rewrite that, sprinkling the algebra, to get 10x cubed plus 5. They're just trying to throw you off there and kind of make you try to do product rule. And we have 5 arc tangent of 2x. So I haven't found the derivative, I've just done a rewrite. The derivative would be 30x squared. The derivative of 5, of course, is 0. Plus, again, remember your derivatives of your arctangent, 5 times u prime, this is u, the derivative of 2x is 2, u prime, over 1 plus u squared. Again, u is 2x, so when I square that I get 4x squared. So I have a final answer of 30x squared plus 10 over 1 plus 4x squared. And again, if you see any errors in my work, please let me know that so that I can let other students know and make any corrections.